Hi there, chemistry students. So I'm not going to be able to be there today. I do have a video here that kind of goes over what we're going to be doing. So take out your packets if you haven't already. I believe I had asked your sub to kind of have you guys just check your answers on pages 6 and 7 of your packet that was due for today. So you should have kind of done that already, but either way, I'm going to kind of go over some of these answers here. Questions 1 and 2 are should be right in your notes here. Question 1, though, we need for the next section, so I will kind of remind us of that. So what is the rule for how many significant figures you're able to use during a measuring instrument? So it's all marked, any marked numbers plus one estimated digit. So you have to go by what are the numbers that are marked on there. Now, that doesn't mean that that there has to be a number next to each thing, but there at least has to be a line next to each of them so you can count, exactly where that line is. And then you can do one extra digit. So let's look at number 3. So this is just how many, sig figs are there in these following numbers. So we got to get really good at practicing this, especially moving on today. So letter A, 2, that's pretty simple. B as well, pretty simple, 4. Letter C. So remember that a trailing 0 is like what this one is at the end, is significant, and we count it if there's a decimal point. And so since there is, I also have 4 for C. D is also 4 because that is a captive 0. E, now with E I have 76,000, but since there is no decimal, and these are trailing zeros, I do not count them. So I only have 2 significant figures for E. Now, if I were to put a dot or a decimal there, then all 5 would be. But since there isn't a decimal, then I assume that these last 3 are kind of estimated. Okay, so my only significant figures are 2, 7, and 6. Letter F, again, just like letter C, this one is significant because it comes after, it's a trailing 0, but there's a decimal. G, there's 3, that's a captive 0. H. So the 0 in front here, that's called your leading zeros. Those are never significant, so there's only 3. Letter I, so I have some captive zeros in there before and after the decimal. I have to count all of them, so there's 5 for letter I. J, I have a little bit of both. So I have some leading zeros here, which I do not count. They're basically placeholders, but they're not significant to my measurement. Obviously, I count the 5, 5, 8, 7, and I do count this 0 because this is a trailing 0, but I do have a decimal in here, so that tells me that I have measured that out to that point exactly. So 5 for letter J. All right. So number 4 here, hopefully this will make sense here if you were a little bit confused, but it says take measurements from the following pictures. Record your answer to the with the appropriate number of significant figures. So again, our rule states that, any marked numbers plus 1 extra. And so in this case, I have a 4 and a 5, right? And I don't have any lines in between except for like a halfway mark. But that only tells me 1 out of the 10, numbers that are technically, maybe within here, like 44.1, 44.2. So my only numbers that I know is that it's between 4 and 5. All right. So that'll be my only known digits. So you would write, a 4 right here. Okay. Now I can estimate out one more digit. All right. And so when I look at this, if I kind of pull it down, I would, good estimate might be 4.8. Right. Again, I can't say that I know that the 8 is certain. That's my uncertain one, but I know for sure that it's 4. Okay. Now, take a look at this one. This is almost the same ruler, same piece of paper here, whatever, but also look at that edge there. It's ripped. This one's nice and clean. For this one here, see how I have these lines marked in between? So even though there's a 4 and a 5, I know exactly that this line is 4.1 centimeters, 4.2, 4.35, whatever. So these all count as marked lines on here, and I can go ahead and use those as my main digits. So if I look here, it looks like it goes out in between maybe the 5 and the 6. All right. Actually, no, it looks like it's right lined up on the 5. Okay. So since it's lined up at the halfway mark exactly, and I can definitely see that one, and I know all these other ones are what those are, I can say 4.5. That's what I'm certain of. And then I have an extra digit that I can use here. If I think it's 4.5 exactly, then I'm going to still add a 0 onto the end of that, because these two numbers are the 4 and the 5. I know for sure. My 0 is my estimation. All right. So you can see the difference of how I can, go one more significant figure when I have these millimeter mark lines on here and much more precision. Okay. So I wouldn't be able to do that without it. Now the graduated cylinder is the same way. So I have 21 and 20. So that means each of these lines is actually like 21.1, 21.2, 21.3, 4, 5, 6, and then all the way up. So since, again, all these lines are technically marked, again, it doesn't say next to each line 21.6, 21.7. It doesn't say it because they could not fit all those numbers on there. But it does, I do know where that is. So I can imply here that I have two significant figures. I know that it's 21, and I know that it is above the 0.6. So 21, all right, and then 0.6. Righty. Now, my last digit that I can estimate is what's, kind of in between here. So since it's not halfway, it's a little under half, I would say maybe 3. So my last number that I would add here would be 3. So 21.63 would be the best way to do this measurement. Again, I know for sure it's 21.6, right? Because I can easily see the 0.6 it's marked. The 3 is my estimated line. All right. So what I'm going to have you do is take a few minutes and do a little bit more practice with this with bell work number 2. So open up to page 2 in your packet and do bell work number 2. So practice that with these 3 here. Or 4. There's 4 questions there, sorry. All right. I'm going to, let's see here. I'm going to look over those answers with you tomorrow. So if you're not quite done looking at that or estimating that, just make sure you have that done for tomorrow. In the meantime, I'm going to have us go to, it probably would be page 8 in your notebook or your packet here. And it should be the, yeah, it should be this one right here. It might look a little bit different on your end because this is an older file that I had changed, but this is the one that we're looking at here. So you're looking for this example box right there. So next page after the worksheet, which is page 8. So what I'm going to do is I'm going to show you a video. I'll kind of be narrating the video along with the person who is talking. But so I'll pause the video if we kind of need to here, but you should be able to get most of that from this video here. So we're going to fill in those notes. on page 8 in our packet.
Hi, chemists. Welcome back. We will be performing significant figure calculations. By the end of this video, you will need to know and apply the rules for significant figures and calculations, perform basic multiplication, division, addition, and subtraction, and round to the appropriate number of sig figs, and then write your answer with the appropriate units. You learned already how to identify the number of significant figures in a number. So for example, in number 1, the zeros in front are leading. They are never significant. That means that the 2 is the only thing that is significant. In number 2, there are 2 types of zeros in this number. There are leading zeros and there's a trailing zero. The leading zeros, again, are the numbers that are in front of the non-zero digit. So in this case, those 2 zeros in front are not significant. Trailing zeros, on the other hand, are a little tricky because they are sometimes significant. They are only significant when there is a decimal point. Since there is a decimal point in this number, that means both the 2 and the 0 are significant. In the following number, these 4 are all significant. Notice there is a trailing 0 and there are captive zeros. Remember, captive zeros are always significant and trailing zeros are not significant when there is no decimal point. Therefore, there are 4 sig figs in that number. In the number 20,000, the zeros at the end are trailing zeros, and there are no decimal places, and so therefore, the only thing that's significant is the 2. Scientific notation is a little bit easier because the coefficient tells you exactly how many sig figs there are. So in the number 2.0 times 10 to the minus 3 meters, the 2 and the 0 will be the ones that are significant. And last but not least, in the number 2002, there are captive zeros. They are always significant. That means that all 4 are going to be significant. So hopefully that was a good review for you how to identify the number of significant figures. Now we move on to calculations. When we look at addition and subtraction, the good news is that it follows the same rule, and you need to focus on the decimal places. What this means is that your answer is rounded to the same number of decimal places as the number used in the calculation with the least number of decimal places. So for example, if you...
I'll pause that here so you can write that down. So we have different rules for addition and subtraction versus multiplication and division, but addition and subtraction are the same rules. So I don't have a different rule for addition and a different one subtraction. It's just for addition and subtraction, I have one rule. Multiplication and division, I have another. So for addition and subtraction, you need to look at the decimal places. So any, numbers after the decimal. So the answer is rounded to the same number of decimal places as the number used in the calculation with the lowest or the least amount of decimal places. All right. So the least one is the one that you have to remember here. So the least number of decimal places between these two problems here is what you would want to use. So I'll let her continue.
You do these 2 calculations. You can use, of course, your calculator. These are the 2 answers that you'll end up with. But according to the rules of significant figures, you are going to have to round your answer to the least number of decimal places in the numbers that you're adding or subtracting. So for example, on the left-hand example, I highlighted in blue the 0.7. And the reason why I did that was because that is showing 1 decimal place to the right versus the other number, which is 2 decimal places to the right. That means your answer should only be 1 decimal place to the right. In the second example, I highlighted in blue the 1 and the 2. There are 2 decimal places to the right versus the other number, which has 3. Therefore, your answer should only have 2. Let's talk about rounding. Typically, the rule is if the number to the right is 5 or above, then you round up. If it's anything other than that, then you chop it off and you don't have to do anything with it. So that's why the answer on the left is going to end up being 7.8 meters. The answer on the right, however, you will have to round that 7 up to an 8. So that's why your answer will be 5.78 grams. This takes practice. So here are some more examples.
So just as a reminder there, make sure that you don't, do the whole addition, subtraction, everything first. Get a number, and you can make this number go out a little bit. This is all it's going to go out because of what you're given. But you can write out the whole number and then go ahead and lob it off or cut it off or round it. To what you need to. So I usually recommend writing out the final number that you get and turning that into your rounded number.
This takes practice. So here are some more examples. When you do this calculation, your answer is 3.770. I always recommend writing out the entire number. When you round it, again, your answer is rounded to 2 decimal places to the right because it has the smallest amount of decimal places. That 4.00 has the smallest. So that's why your answer would be 3.77 centimeters. In this next example, when you do the calculation, you end up with 12.93. But again, the number 5.0 has 1 decimal place to the right, so therefore your answer has 1 decimal place to the right. Notice that you don't round up because there's a 3 next to the 9, and so you'll end up with 12.9 grams. In this subtraction problem, notice we have 1 decimal place to the right. That means our answer can only have 1 decimal place to the right. So therefore, we do have to round up, though, because there is a 5 next to the 4. So it'll be 98.5 milliliters. In this one, we're adding 3 different numbers. Don't worry, it's not that complicated. You just do the exact same thing that you did before. So notice out of all the numbers that you're adding, the smallest number of decimal places is the middle one. And so that's why your answer will have to be rounded 1 decimal place to the right. But it does round the 3 to a 4, so that's why the answer will be 11.4 centimeters. Let's talk about multiplication and division. So the bad news is that it follows a different rule. But I guess there's good news in that it follows the same rule, so that's a little bit easier. So for multiplication and division, this is a little bit different because you have to look at the total number of significant figures that you're multiplying or dividing. So, for example, your answer is going to be rounded to the same number of significant figures as the number used in the calculation with the least sig figs. Notice we are not talking about decimal places here. We are talking about the entire number. So here's some examples. Calculations. Perform.
Sorry about that. Okay, so I'll give you a second to write this down. So as she mentioned, multiplication and division is a different than addition and subtraction. You don't look at decimal places, you look at number of significant figures. But you do the same for whether you're multiplying or dividing. So your answer is going to be rounded to the same number of sig figs as the one with the least number of sig figs. So, we'll go through some examples here. So this is where your sig fig counting is going to become important because you got to know, how many one of them has so you can get, do the least amount as far as the rounding goes. So you're always going to want to extend your number out a little ways when you do this, but you don't have to go out like 15 numbers, like if you get a decimal, a really long decimal. Just go out a little ways because you might have, depending on how many sig figs you have, you might need to, add a little bit more, take off a little bit. Just let her finish this.
Of the entire number. So here's some examples. If you were to do these calculations, this is what you would end up with. So again, I recommend writing out the entire number.
All right, so she did 17.85 grams divided by 2.13 milliliters. All right, and she gets 8.38028. So you notice how she went a little bit beyond that. Again, there's not really a set number. Just go a little bit beyond 4 or 5, maybe that's fine. And now I need to look at, okay, how many sig figs does each number have? Well, you should look at this one. That one's got 4. This one's got 3. So that means that 3 is the lowest. My answer is going to be rounded to the lowest one. And with this one, I'm multiplying these two numbers, and this is what I get. But I think she explains this here too.
Your answer is again going to reflect not decimal places here. Your answer is going to reflect the least number of significant figures in total. Notice in the example on the left, I highlighted in blue the entire number 2.13 because that has 3 sig figs. With the calculation on the right, you can see I highlighted the 3 and the 0 because that has 2 sig figs. What that means is your answer has to be rounded to the number that has the least significant figures in total. So therefore, your answer would be 8.38 grams per milliliter and 0.0017 centimeters squared. Here are some more practice problems. When you do this calculation, you end up with 9.2. Again, your answer is rounded to the least number of significant figures. So that's why your answer would simply be 9 centimeters squared. When you do this calculation, notice the numerator has the least number of significant figures with 2 sig figs. That means your answer has to have 2 significant figures. So when you round this, it'll be 0.64 grams per liter. In this calculation, the first number has the least number of sig figs, so that one has 2, versus the other number has actually 3. So that's why your answer has to have 2. Therefore, you'll end up with 0.0092 milliliters squared. And then again, this may look a little bit more complicated because you have more numbers that you're multiplying. But again, you want to look through and see which one has the least number of significant figures, and the one all the way to the right does. So that means your answer is going to be rounded to 2 sig figs, and therefore it'll be 0.54 centimeters cubed.
All right. So with that, what I'm going to have you guys work on now is worksheet. Let's see here. All right, I thought I had this pulled up. All right, so it should be the next page there. This is worksheet. It says number 6 on here again. Yours should say number 2. But it should be significant figures and calculations. All right, so number 1 says round the following numbers to the number of sig figs indicated. So all you're going to do with this one is it's just telling you, it's practicing with rounding. All right, so it's saying, okay, 345, I want that rounded to 2 significant figures. So that does not mean that I just lob off the 5 and, maybe round that to 5 and then put 35. That's what I will have some students do. They think that because I'm asking to decrease my number of sig figs that I don't want the same, number here, but I do. It needs to have 3 places. It needs to be 300 something. Okay. So the best way to do this is, okay, 2 significant figures. So that means I'm going to go to the 4. All right. So the 3 and the 4 should be my 2, significant figures, but I want to look at rounding. All right. So with rounding, I look at the next number after, which is a 5. That tells me that the 4 needs to come up. So your answer for this one should be 35. Right, or sorry, I just did it. Your answer for this one should be 350. Okay, so I just made the mistake I told you not to. So again, I look at what number do I need to round to? Okay, and either stick with that number if it's below 5, or round up if it's above 5, and add a 0 for the placeholders. All right, so let's do B quick. So I had 7,850. I only want this rounded to one significant figure. So that means it's going to be this number here that I'm looking at. So does it stay as 7 or does it get rounded up? Looks like it gets rounded up because I have an 8 here. All right, so this one should be 8, and then I still need to make sure I have the same number of places, but I'm going to fill these in with trailing zeros that are not significant. So that one should be 8,000. All right, now letter C is a little bit more difficult. Because I have to apply the other rules as far as sig figs go. So 24.68, if I was following the rules that I did up here, I would lob this off or look at the 6, right? So 24.68, that tells me that I'm going to round that up to 24.7. Right now, like I said, if you're following the rules that we did just before, that you might think, okay, now I just fill in a 0 for the placeholder like this. But let me show you, how many sig figs does this have now? That has 4, because that 0 tells me that that's exactly 0. So in order to round this to 3 significant figures, it just needs to be 24.7. So in this case, I don't even keep the placeholder anymore like that. I'm rounding to get rid of that trailing 0. So I only have 3 significant figures. Okay. So let's look at letter D. It's going to kind of be something similar here. So as far as significant figures, I only want 3. All right, so that brings me to this right here. So this 0, all right, I needed to see if that stays or I round up. It looks like I round up. So that means that that is going to become 8.0, and then that'll be a 1. So that has 3 significant figures. I would not add a 0 behind that, to replace that 5 that I got rid of, because then I would be adding significant figures, and that's not what I want to do. Okay, letter E, you're going to be looking at what do you need to do to get 3 significant figures. So again, these first 3 zeros, those are not significant, so I don't start counting until here. So the 5, 7, 5. So this, number here is what I need to look at in terms of rounding. So I know that it's going to be 0.0057. Okay. Now, if I look, this 5 here, since that's an 8, that needs to get rounded up, and that gets rounded to 6, and I need 3 sig figs, so I'm good right there. So again, I would not add that last 0 there. And with the last one here, it says 1.25 times 10 to the 12th. So for this one, and for any of them that include powers, scientific notation, as she said in the video, it kind of makes it easy because whatever's written here is exactly how many sig figs I have. So I don't need to write out this whole number because none of those zeros that would come after this big number that I would have to write out are significant. So the only ones that are significant are actually as the coefficient. So I just need to mess with the 1.25. 2 significant figures means I'm going to stop right here. And then I got to go ahead and, since that's a 5, round that up. So pretty much all of these I've been rounding up, but you're not always going to see that. So this becomes 1.3, but then the rest of it will stay the same. Okay. So you'll just put this in right after that, and that stays the same. So you don't move your decimal any places. You're not monkeying with your exponent. The only thing you're doing is lowering your significant figures. Okay. All right. So I'm going to have you do the rest of these pages here for tomorrow. Just practice on the math here. Again, once you have an answer, go ahead and write it out, the whole number, and then you can worry about getting to the correct sig figs or decimal numbers. So for number 2, these are all adding or subtracting. So make sure you're looking at the rule for that. That's decimal places. And then for 3 and 4, you are doing multiplication and division. So make sure that you are looking at number of sig figs in terms of rounding. The second page of your worksheet here says express the answer of each of the fine calculations in scientific notation with the correct number of significant figures. If you want, I might leave this one for us to do maybe in class, just to give you some examples of this on Wednesdays. So if you feel comfortable enough that you want to attempt this, go right ahead. If you want to just, kind of work on the multiplication and addition part and get that down, that's fine too. So I'm only going to require the very first page here of that packet or worksheet number 2 to be done. And we've already done all of number 1. So you just need to do 2 and 3 for tomorrow. All right, I will stop this video here.